Welcome to video 9.7a, derive the ratios of a 30-60-90 right triangle and a 45-45-90 right triangle. This is an extra sheet that hopefully you have in your notes booklet. It's not in your normal notes. All right, so first let's derive the 30-60-90 ratios. To do that, we start with an equilateral triangle, 60-60-60, all sides congruent. It makes it easier if we just call the sides 2, 2, and 2. Now there's one thing you've got to realize. We had a theorem before that said whenever you've got an isosceles triangle and you drop an altitude from the vertex angle, it does two things. It bisects the vertex angle and it bisects the opposite side. So if this whole angle here was 60, it's now chopped up into 30 and 30, and if this whole side here was 2, this part here is 1. We now can focus on this 30-60-90 right triangle. And we have a side length, a leg of 1 and a hypotenuse of 2. So now I can go ahead and find that altitude using the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. So a squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. A squared equals 3. A equals the square root of 3. That's where the ratios come from. So from now on, I'll just draw it a little bit bigger. Whenever I have a 30, 60, 90 right triangle, the ratios are always 1, radical 3, and 2. Now, it makes it easier if we use a variable x, so I'm going to rewrite it this way. 30, 60, 90, x radical 3, and 2x. It's important to note that opposite the 30-degree angle is x. Smallest angle, smallest side. Opposite the 90-degree angle is 2x. Largest angle, largest side. Opposite the 60 is x radical 3. Middle angle, middle side. And we're going to use these in some examples coming up. So once again, this is how you derive the ratios for a 30, 60, 90 right triangle. Now let's go ahead to the 45, 45, 90 right triangle. To do that, we start with a square. I just made the side lengths be 1, 1, and 1, and then we draw a diagonal. Now for a square, when you draw a diagonal, it's going to bisect those angles. So if the angle was 90 and I bisect it, I get a 45 and a 45, and that's where the 45, 45, 90 right triangle comes from. So just draw again right here. 45, 45, 90, 1, 1, we'll call that D. Diagonal. Use the Pythagorean theorem again. So leg squared plus leg squared equals hypotenuse squared. 1 squared plus 1 squared equals D squared. 1 plus 1 equals D squared. D squared equals 2. So D equals the square root of 2. Okay, so the ratios of a 45, 45, 90 right triangle will always be in the ratio of 1 to 1 to radical 2. Again, we'll use x just to keep it easier in the future. X radical 2. Very easily, going from a leg to a hypotenuse, we multiply by radical 2. Going from a hypotenuse to a leg, we simply divide by radical 2. And there you have it, how to derive the ratios of these two special right triangles.